Honors Pre-Calculus Final Exam Review, number 62. I'm going to do number 62 again because right after I finished the previous one, I found a much easier way to do it. But I think both ways are valuable to look at in case you didn't see the easy way right away and you did it the long way like I did. And I want you to see that both of those ways are legitimate. But this is a much easier way that I thought of after the fact. So this is 1 plus tangent squared minus 1 minus sine squared x equals 1. So this is, I've changed the problem into x instead of s. Now, so what we're going to do is to take advantage of another form of the Pythagorean identity. Now, there's Pythagorean identities involving tangent squared and secant squared and cosecant squared and cotangent squared. I personally don't memorize any of them. What I do instead is I only remember the important one. The important one is cosine squared plus sine squared equals 1. And then I remember that there is one about tangent squared. So if I want to get one about tangent squared, then what I'll do is I'll say, well, how would I get tangent here? I would divide this by cosine squared, because sine squared over cosine squared is tangent squared. So if I divide all three terms by cosine squared, then I can see that, let's see, cosine squared divided by cosine squared is 1. Sine squared divided by cosine squared is tangent squared. And 1 divided by cosine squared is secant squared. So this is another Pythagorean identity. And by the way, some people just memorize this Pythagorean identity. And if you've done that, that's an advantage for this particular problem, because instead of foiling it out like I did last time, oh, that's not this one. Is that the one? Where's the one that I just did? Oh, I'm not sure, but last time I foiled it out like this. So if I foiled it out, I had this big difficult problem. But if instead I change the 1 plus tangent squared to secant squared, so we're just going to replace this with secant squared according to this identity. So I have secant squared now times 1 minus sine squared x equals 1. Now I'll take advantage of another thing that I said last time, and I said we should always be aware of this, and then I wasn't aware of it. 1 minus sine squared. We know that 1 minus sine squared is always just cosine squared. So now I have secant squared times 1 minus sine squared. We're going to replace that with cosine squared. So what I like about this is the problem keeps getting simpler and simpler instead of more and more complicated. So now I have 1 over cosine squared x. I'm going to put everything in terms of sine and cosine now. So secant squared is 1 over cosine squared times cosine squared x equals 1. And now I like the way these line up because they cancel out. And I just have 1 equals 1. Done. Now, this is a much simpler way to do it, but I think comparing the two is very instructive because there's a clever way to do this and a laborious way to do this. You might see the clever way right away because you're very fluid with your Pythagorean identities, or why I did it this way is I fell into a habit of always foiling, and so I ended up doing it the long way. But what's instructive about that is either way I end up with something true. It doesn't have to be 1 equals 1 in both cases. It could have been cosine squared equals cosine squared. But either way, I've taken what I was given, I changed it into something identical to itself, so an identity. And there's two different ways to do it, an easy way, a hard way, but they are both legitimate. So it's instructive, I think, to look at both ways of solving number 62.